Welcome to Trending Unpacked, the show where we break down the stories everyone's talking about and explore why they matter. Today, we're looking into a name that probably just sent a bit of a shiver down your spine: kissing bug disease. Just the sound of it conjures up this really vivid, almost cinematic image, doesn't it? It's unsettling, it's memorable, and, well, frankly, a little creepy.
It absolutely does. And that gut reaction, that's really key here. The name itself, it's less a medical term, more like a story packed into two words, It immediately paints this picture of something intimate, but also quite dangerous.
Right.
And what's particularly interesting now in 2025 is that while Chagas disease, that's the actual condition that's been studied for, well, over a century, the kissing bug nickname, especially amplified by recent media reports and increasing sightings, has really pushed it back into the global spotlight.
Suddenly urgent, yeah.
It feels that way, yes. Even though the underlying threat, it's been simmering for a very long time.
And that sense of urgency you mentioned, that's crucial, because we're not talking about some brand new disease here.
No, not at all.
But what is new, or feels new, is the rising number of reports about these insects, these kissing bugs, popping up across the southern U.S. and Central America. For many of us, I think this shifts it from being some abstract, far-off threat into something with, well, alarming local relevance.
Exactly.
It feels like it's no longer just a story happening somewhere else. It feels like it could be, knocking on our own back doors.
Precisely. And we need to be clear, this isn't just about an annoying insect bite like, say, a mosquito.
Right.
We're actually discussing a parasitic infection here, one that carries the potential for some profoundly serious long-term health problems. And these effects, they often remain completely silent, undetected for years, sometimes even decades, until, unfortunately, the damage is already done, often irreversibly. It's this hidden progression, this sort of clandestine danger operating below the radar of public awareness that really gives our discussion today its eerie, intelligent feel. It's a disease that kind of whispers rather than shouts until it might be too late.
That's a really powerful way to put it, a disease that whispers, and that's exactly why we're here today. Our mission is to look beyond those sensational headlines. We want to understand the intricate science behind kissing bug disease, explore its broader societal impact, and maybe most importantly, figure out exactly what you truly need to know about this trending and frankly quite unnerving topic. So let's unpack this silent menace.
Let's do it. Let's pull back that curtain.
Okay, so to start, let's properly identify the main character here, the kissing bug itself. We've heard the nickname, it's evocative, a bit unsettling. But what are these insects, scientifically speaking? What's their actual identity?
Right. Scientifically, they belong to a specific group of insects known as triatamine insects, or triatamines.
Triatamines, okay.
Using that proper biological name, it immediately helps ground the discussion in reality,
Yeah.
It moves us away from the slightly folkloric image that kissing bug might create. It reminds us these are real creatures. They have specific biological characteristics. They're not some urban myth. They're part of a larger ecosystem.
Makes sense. Grounding it in biology.
Understanding them starts with understanding that identity.
So triatamines, got it. What do they actually look like? If you were to encounter one, what should you look for? And what is it about their behavior that's earned them this reputation?
Well, these triatamine insects, they're primarily blood-sucking bugs. That's their main thing. Size-wise, they can vary quite a bit. Maybe half an inch, sometimes over an inch long. They often have this quite distinctive cone-shaped head.
Cone-shaped head, okay.
Yeah, and many species have sort of flattened oval bodies. Coloration can range from dark browns, blacks. Sometimes they have these red or orange or yellow markings along the edge of their abdomen.
Right.
But crucially, they are predominantly nocturnal, active at night.
Ah, okay, that adds to the unease.
It does, significantly.
Yeah.
It means they're most active under the cloak of darkness, which already contributes to their unsettling mystique. The creepy factor, as you put it, really stems from their behavior. They tend to bite humans, often on the face, particularly around the eyes or the mouth, typically while we're deeply asleep.
Oh, wow. Okay.
So imagine that, a silent, maybe winged insect approaching you in the dark, seeking a blood meal, literally from your face. It's a deeply visceral, unsettling image.
Yeah, it really is.
And that's precisely why the kissing bug name and the fear it generates has taken such a firm hold in the public mind.
That image alone is probably enough to make anyone double-check their bedroom. You mentioned they're nocturnal, preying on us when we're most vulnerable. Where are these creatures traditionally found? Is this a global thing or more concentrated?
Historically, overwhelmingly, they're concentrated in the Americas, specifically Central and South America. They thrive in tropical and subtropical climates. Often they make their homes in cracks and crevices of housing, particularly substandard housing in rural, often impoverished areas. This geographical scope is important. It gives us a baseline for understanding their presence.
Right, knowing where they were helps understand where they might be going.
Exactly. Knowing their traditional habitats helps us put their recent expansion into context, which is a huge part of why we're talking about them so much now. That image, of these insects active in the dead of night, it really underscores the discomfort many feel. They're literally creatures of the dark, operating when we're most helpless.
Yeah.
It contributes significantly to their unsettling reputation and makes them, well, perfect subjects for those trending scary bug stories online.
Okay, that brings us to maybe the most critical distinction here, and probably a common source of confusion.
Yeah.
We know the bug bites, but how exactly does Chagas disease actually get transmitted? It's not just the bite itself, is it?
No, and you hit on an absolutely crucial point. It often gets lost in the sensational headlines. The actual agent responsible for Chagas disease isn't the bug directly, but a specific microscopic parasite it carries. It's called Trypanosoma cruzi.
Trypanosoma cruzi.
Think of the kissing bug, basically, as a vector, like a taxi for this tiny, insidious passenger.
Right.
But here's the really key twist. It is not the bite that directly infects you. That's a common and, frankly, dangerous misconception.
So the bug bites, takes blood, but it doesn't inject the parasite like, say, a mosquito injects malaria parasites.
Exactly. That's not how it works here.
How does a parasite get into a person then?
This is where the unique and honestly quite insidious transmission mechanism comes in. It's vital everyone understands this. Transmission does not happen directly through the bite wound itself. Instead, as the kissing bud feeds, and it often does this painlessly thanks to an anesthetic in its saliva so it can go unnoticed while you sleep it frequently, defecates, poops, near the bite wound.
Oh, lovely.
Yes. And the parasite, Trypanosoma cruzi, is present in the bug's feces. Now, if those feces are then inadvertently rubbed into the open bite wound, or perhaps into a mucous membrane like the eye or the mouth, maybe by the sleeping person scratching the itch, that's when the parasite can enter the bloodstream and cause the infection.
Wow. Okay, so if I'm hearing this right, it's a two-step process. First, the bite, which you might not even feel.
Right.
Followed by an unconscious action, like scratching or rubbing your eye, that actually introduces the contaminated feces into your body.
Precisely.
This is such a vital piece of information. It immediately sets Chagas disease apart from other insect-borne illnesses like malaria or Zika, where the pathogen is injected with the bite.
Yes, a completely different
It
mechanism.
makes the whole window for prevention or even awareness much more nuanced, doesn't it?
It absolutely does. This indirect method is what makes Chagas particularly treacherous. Like you said, the initial bite itself is often painless, easily dismissed, maybe it's just a mosquito bite or some other minor irritation. You might wake up with a small itchy spot.
Right. Nothing alarming necessarily.
Exactly. The real danger starts when you unconsciously scratch that itch, or maybe rub your eye in your sleep, and inadvertently introduce the parasite from those fresh droppings into your system. This subtle, almost accidental transfer means the actual moment of infection isn't some sharp, painful event that signals danger. It's quiet, unheralded.
Clandestine, as you said earlier.
Clandestine is the perfect word. This pathway makes early detection incredibly difficult, allowing the disease to take root without any fanfare, contributing significantly to its long-term, often devastating potential. It's a truly deceptive mechanism.
That really hammers home the silent threat aspect we touched on. So let's talk about those threats. Once the Trypanosoma cruzi parasite has managed to get inside a person, what happens? What are the typical symptoms, if any, and what are the long-term health impacts?
Okay, well, just for context, Chagas disease was first described really meticulously back in 1909 by a Brazilian physician, Carlos Chagas.
Over 100 years ago.
Yeah, so we've had a long time to study this condition and its effects. When it comes to symptoms, the disease typically unfolds in two distinct phases. And the first one, as you said, is often the silent one, making diagnosis incredibly challenging.
Let's start there then. The acute phase. What does that usually look like? Or, maybe more importantly, what does it not look like that makes it so hard to catch?
Exactly. The initial or acute phase of Chagas disease is frequently characterized by mild symptoms, or, critically, no symptoms at all.
None.
Wow,
Wow.
often none. And this poses a massive challenge for diagnosis. If symptoms do appear, they're often very nonspecific. Easily mistaken for, the common cold, the flu, maybe just feeling a bit run down.
Like fatigue, maybe a fever?
Yes, exactly. Fever, fatigue, body aches, headaches, sometimes a rash. Occasionally there might be a localized swelling right at the bite site. That's called a chagoma. Or if the parasite happened to enter through the eye, there's a characteristic swelling of one eyelid known as Romagne sign.
Okay, Romagne sign. But these aren't guaranteed.
Not at all. And even when they do occur, they're often fleeting, or so subtle that people just dismiss them. Think about it. How often do you get a slight fever or feel tired?
Right, you just push through it.
Precisely. It's estimated that in some regions where it's common, maybe up to 70% of people might live with Chagas disease for decades, completely unaware, because this acute phase offered no clear warning sign. This silent nature is exactly why diagnosis is so difficult. It lets the parasite establish itself and progress undetected within the body, sometimes for years, sometimes decades, before the really serious, irreversible problems start showing up.
That's genuinely alarming. If you don't even realize you're sick, how could you possibly seek treatment? So if this acute phase often goes unnoticed, what happens next? What are those long-term devastating consequences you mentioned?
Well, if it's left untreated, the parasite doesn't just vanish. It persists in the body. Slowly, relentlessly, it infiltrates and damages tissues. This leads to what we call the chronic phase.
The chronic phase,
Yeah.
okay.
And this is where the truly devastating, irreversible consequences emerge. After a latency period which can last anywhere from, say, 10 to 30 years, sometimes even longer, the parasite can cause severe damage. It primarily affects two major organ systems, essentially turning the body against itself from the inside out.
Okay, which organ systems are we talking about, and what kind of damage does it cause?
First and foremost, the heart. Chagas disease is actually a leading cause of serious cardiac complications in Latin America, and increasingly we're seeing it recognized globally. The parasite doesn't just cause inflammation, it actually infiltrates and destroys nerve cells and muscle fibers within the heart. It essentially rewires the heart's electrical system and progressively weakens its walls.
Wow.
This leads to a condition known as Chagas cardiomyopathy. Victims can suffer from severe arrhythmias, irregular heartbeats, and enlarged heart, which then struggles to pump blood effectively, and ultimately heart failure, which can be fatal.
And this damage is cumulative.
Yes, cumulative, and often only becomes apparent after significant, irreparable damage has already occurred. At that point, treatment options are often limited to managing symptoms. Imagine your heart, the engine of your body, just slowly being eroded, losing its rhythm over decades without you even knowing it's happening.
That's truly a ticking time bomb scenario for the heart. What's the other major system that falls victim to this long, silent attack?
The second main target is the digestive system. The parasite can damage the nerve networks, the plexuses that control the muscles of the esophagus and the colon.
Okay.
This nerve damage leads to a loss of muscle tone, loss of coordinated movement. This results in two severe conditions, one called megaesophagus and the other megacolon.
Megaesophagus and megacolon, meaning enlarged.
Exactly. With megaesophagus, the esophagus loses its ability to contract properly and push food down towards the stomach. It becomes this sort of flaccid, enlarged tube where food just sits.
That sounds awful.
It causes profound difficulty swallowing, regurgitation, chest pain, and it can lead to severe malnutrition over time. Similarly, megacolon involves an enlargement of the large intestine. It loses its ability to move waste efficiently, leading to chronic, debilitating constipation, abdominal pain, and in really severe cases, life-threatening complications like bowel obstruction or perforation.
The stark difference between that initial, often totally silent phase and these later, potentially fatal complications is just staggering. It absolutely underscores why early detection would be so crucial, but also why it's so frequently missed. It really transforms Chagas into this formidable public health challenge, hiding in plain sight for decades.
It really is,
Yeah.
stealthily dismantling the body from within.
Well-
And the scale of this problem is much larger and more dynamic than many people probably realize.
Hmm.
Globally, the estimate is over 6 million people are infected with Chagas disease right now.
6 million.
6 million. Historically, yes, the vast majority of these cases have been concentrated in Latin America, where the disease is endemic, where the bugs are commonly found. But here's where we get to why it's gaining so much traction now, why it's becoming this emerging concern in regions typically considered non-endemic, places like the U.S., parts of Europe even.
Okay, so 6 million people, mostly in Latin America historically, but you're saying it's increasingly seen elsewhere, like the U.S. Why the shift? What's driving this resurgence and geographic expansion?
There are two really significant interconnected factors driving this. The first major one is changing human migration patterns.
Okay, people moving around more.
Exactly. As people move, whether it's for economic reasons, seeking refuge, or just travel, individuals who are infected, often unknowingly from endemic regions, can carry the parasite to new areas. Now, if the kissing bug vector, the insect itself, is also present and established in these new regions.
And you have the potential for local transmission.
Precisely. Even if the disease wasn't historically common there. Yeah. It's a powerful example of how global human movement now directly impacts public health, essentially creating bridges for diseases to cross old geographical divides.
So the human host and the insect vector can now meet in places they traditionally wouldn't have, potentially completing the disease cycle in new territories. But migration isn't the only piece of the puzzle, is it? We've heard so much about environmental changes lately. Does climate play a role here?
Oh, absolutely. And this is a crucial, deeply concerning point that directly links Chagas disease to these broader global environmental trends,
Yeah.
climate factors, particularly warming climates.
How so?
Warmer climates are directly expanding the potential habitat of kissing bugs. They're pushing them beyond their traditional boundaries. As average temperatures rise, areas that were previously just too cold for these insects to survive year-round, or maybe too cold for them to efficiently complete their life cycles, are becoming increasingly hospitable.
So they can live further north, for instance?
Yes, it allows them to push further north into the U.S., potentially establish new populations in areas where they weren't found before. This creates entirely new zones where both the insect vector and the potential for transmission can exist. It's turning what was once considered a more localized regional concern into something with much broader, potentially global implications.
That's a direct, almost chilling link between climate change and our immediate health risks. So warming temperatures are basically rolling out the welcome mat for these insects in new places. What's been the response from official health organizations to this? Are they seeing this trend?
Yes. Health agencies worldwide, including organizations like the World Health Organization, the WHO, and the Centers for Disease Control and Prevention, the CDC here in the U.S., they have definitely recognized these shifts. They've stepped up their efforts. They're issuing new warnings and guidance about monitoring for and preventing exposure to kissing bugs and the associated risk of Chagas disease.
So it's on their radar.
Very much so. And this isn't just about, putting out pamphlets. It signals a heightened level of official concern, a recognition that this is a legitimate public health issue requiring proactive attention, surveillance, and action. It's moving beyond just focusing on those traditionally endemic areas.
That's a critical validation, isn't it? It shows this isn't just internet hype, it's a recognized public health threat that agencies are responding to. If we connect this to the bigger picture then, what do these expanding habitats, driven largely by climate change, mean for future public health strategies? Does it fundamentally change how we think about local versus global diseases?
It absolutely forces a rethink.
Yeah.
Those traditional lines we used to draw on maps, marking endemic and non-endemic zones for various vector-borne diseases, they're rapidly becoming blurred, obsolete even.
Yeah.
We're forced to reconsider our entire approach to disease surveillance, our public health education campaigns, even how we train doctors in areas that historically just haven't had to deal with Chagas disease. What was once considered a local disease, primarily of Latin America, is now, because of this confluence of climate change and human mobility, becoming a potential local disease in the southern U.S. and increasingly in other temperate zones around the world.
So we need to be more proactive.
Much more proactive. An anticipatory approach to public health. We can't just react to outbreaks anymore. We need to try and predict and prepare for where diseases might emerge next. It means allocating resources differently, training healthcare providers, educating communities in places where Chagas was once completely unheard of. It has significant implications for global health collaboration, definitely.
Okay, let's shift gears slightly now and talk about how this whole story, with its really unsettling name and this silent, creeping threat, has played out online. We know social media amplifies pretty much everything. How has it treated the kissing bug phenomenon? It seems almost uniquely designed for viral content.
You are absolutely right. Social media platforms think about their visual nature, their speed. They act as incredibly powerful amplifiers for any story involving, well, creepy bugs.
Yeah, people react strongly to bugs.
It's often a primal, visceral reaction, immediate. When you combine that natural human aversion or fascination with insects, especially ones that bite, with a name as evocative and unsettling as kissing bug disease, you basically have perfect viral fuel. It's potent, highly shareable, and often very emotionally charged content, almost tailor-made for the digital age, unfortunately.
A perfect storm for grabbing attention online. But does this amplification always line up with the accurate scientific understanding of the disease? Or does it often sort of veer off course?
Not always, no. In fact, quite often it veers significantly off course. There's a really notable and concerning disconnect between the official data-driven understanding of Chagas, its epidemiology, its transmission nuances, the actual risk levels, and the narratives that circulate online.
Which tend to be more sensational.
Exactly. Social media tends to amplify the creepy bug angle, making the disease sound far more widespread, far more immediately dangerous, and more universally prevalent than the official data actually suggests. It's almost like the horror movie version of the disease is the one that trends, not the more nuanced, complex scientific reality. That reality struggles to cut through the noise.
And what's the psychology behind that? Why do those more sensational versions often gain more traction than the accurate, measured information?
Well, it really boils down to some fundamental drivers of online engagement: fear and novelty.
Fear sells, unfortunately.
Fear is an incredibly powerful motivator online. It grabs attention instantly, it evokes a strong emotional response, and it compels people to share, either to warn others or just to seek more information because they feel personally threatened. And the novelty factor, an emerging or resurfacing threat in a new area, especially one with such a memorable and creepy name, it makes it stand out dramatically in that constant flood of information we all face.
Right.
Unfortunately, this often comes at the direct expense of accuracy and nuance. The more alarming, the more shocking, the more dramatic the claim, the more likely it is to spread rapidly online, sometimes completely, regardless of its factual basis.
That leads us right into the inevitable myths and misconceptions that spring up in these online discussions, doesn't it? What are some of the most common ones you've seen spreading?
Oh, definitely. Online discussions fueled by that fear-driven virality we just talked about, they frequently exaggerate the risks and oversimplify really complex biological processes. This leads to the rapid spread of misinformation that can be genuinely harmful. One very common myth is the idea that every single kissing bug bite immediately transmits Chagas disease.
Which we now know is not true.
Right. We've clarified that the transmission is much more complex. It requires the bug's feces getting into a wound or mucous membrane. But online, that critical nuance often gets completely lost. This leads to this perception that any encounter with a kissing bug is an immediate guaranteed infection, which can cause totally unnecessary panic.
So oversimplifying the transmission, are there other common myths, maybe about how widespread the bugs are?
Absolutely. Another really prevalent one is that these insects are suddenly everywhere, posing an immediate, omnipresent threat in every backyard across the country or across continents. Now, while it's true their habitat is expanding and sightings are increasing, particularly in places like the southern U.S. and Central America, this doesn't mean they are in imminent danger in every single community, or that every bug someone sees is infected or even capable of transmitting the disease.
Right, context matters.
Immensely. The online narrative often creates this sort of generalized sense of imminent pervasive danger that doesn't really align with the more localized, albeit expanding, nature of their actual presence and risk. And this generalized exaggeration can lead to problems on both ends: unnecessary panic, or conversely, people dismissing all warnings because they recognize the hype and then disbelieve even the legitimate public health advice. It's a really tricky balance.
And we can't ignore the undeniable pop culture creepy factor these bugs have. There's just something about that specific imagery, bugs biting people near the mouth while they sleep, that just grabs our imagination, doesn't it? It feels almost cinematic.
It absolutely does. That specific detail, the nocturnal biting near the mouth, literally stealing a kiss while you're completely vulnerable, it taps into a really powerful, almost primal fear. It's an invasion of a very personal, intimate space while you are totally defenseless. This cultural fascination with such an unsettling image is a huge part of why the kissing bug narrative resonates so strongly, why it becomes such compelling online content. It feels like a deep violation.
It almost sounds like something straight out of a horror movie script or a psychological thriller. This idea of an unseen predator in your own home feeding on you while you sleep.
Precisely. You've nailed it. This imagery connects directly to common tropes in horror fiction or thrillers. The idea of a silent nocturnal invader feeding on you when you're most vulnerable, and potentially leaving behind not just a bite, but this life-altering silent disease that incubates for decades. It taps into really deep-seated anxieties.
Yeah.
Anxieties about unseen threats, about bodily autonomy, the sanctity of our homes. It is quite literally the stuff of nightmares. And this horror-like appeal is what makes the stories so sticky, so shareable, and so impactful culturally. It drives virality far more effectively than, say, dry scientific data ever could.
It's a fascinating paradox, though, isn't it? This horror-like appeal definitely raises awareness, like you said. But does it also complicate the scientific understanding? Does it make people more vigilant in the right ways, or just needlessly fearful of the wrong things, maybe missing the actual nuanced risk?
That is the core tension. It's a profound double-edged sword. On one hand, yes, the creepy factor undeniably raises awareness. People hear kissing bug, they're immediately intrigued, maybe they Google it, maybe they learn about Chagas disease for the first time.
What could be good?
It can be good. This heightened attention can prompt some people to seek legitimate information, maybe be more vigilant about potential sightings or consider actual preventive measures. However, on the other hand, it very often leads to a significant misdirection of fear. People might become overly anxious about any bug bite or about an insect that looks vaguely similar but doesn't even carry the parasite, while completely overlooking the more complex and insidious nature of the actual transmission risk and the crucial long-term consequences.
So focused on the scary bug, not the silent disease it might carry.
Exactly. It influences individual behavior by creating this collective anxiety that isn't always proportionate to the real nuanced risk. And that makes it much harder for clear public health messaging to cut through the sensationalism and convey accurate, actionable information about what really matters.
That's a powerful point about misdirected fear. All right, let's try and tie all of this together now in our analysis. Given everything we've discussed, the biology, the silent spread, the climate links, the social media amplification, why now? Why are people seemingly more concerned about Chagas disease in 2025 than they might have been, say, 10 or 20 years ago? What's the confluence of factors?
It really feels like a perfect storm of factors converging right now to create this heightened concern. First, as we touched upon, there's this growing expert concern about significant underdiagnosis in non-endemic countries. This isn't just a small issue, it's potentially a major blind spot in public health systems. Often because doctors in places like the US or Europe simply aren't trained to look for Chagas, or they might attribute those vague initial symptoms to more common illnesses.
So it was likely more present than we realized.
Exactly. This quiet, unacknowledged presence probably existed for years, creating a sort of fertile ground for concern once things started becoming more visible.
And what made it more visible?
That's the second factor, a dramatic increase in visibility and media attention. This is a direct result of combining those real epidemiological shifts, the increased sightings of the insects, indicating genuine habitat expansion, with the incredible speed and reach of social media. When those two things align, a real trend plus rapid communication, a previously overlooked or localized concern can very quickly explode into a widely discussed and often, yes, sensationalized global topic that dominates news feeds.
And we also have to factor in the role of official warnings from public health bodies, right? That lends it legitimacy.
Absolutely critical.
Yeah.
The third factor is the issuance of those new warnings about monitoring and preventing exposure by respected health agencies like the CDC or the WHO. That fundamentally shifts the conversation. It elevates from just being internet chatter or isolated reports to being a recognized legitimate public health issue. When official bodies weigh in, it lends significant credibility and makes the public and policymakers pay much closer attention. So for you, the listener, this convergence of previously underdiagnosed cases, increasing insect sightings, massive social media amplification, and now official warnings all means that you are simply hearing about Chagas disease more now. Even if the underlying risks have actually been quietly growing for quite some time, it's really a spotlight moment for a long-standing, but often tragically overlooked health challenge that seems to have finally reached a kind of tipping point in public consciousness.
It's such a stark reminder of how interconnected everything is, how seemingly distant environmental changes can have these very direct, very local health consequences. Which brings us back to that critical point, the impact of global warming and deforestation on disease risk. We touched on it, but can you elaborate a bit more on the mechanisms? How does warming actually help these bugs and this disease?
Right. This is a monumental piece of the puzzle, and its importance is often underestimated in the public discussion. We've established that warmer climates are expanding the potential habitat of kissing bugs, allowing them to survive and thrive in new regions. This isn't just a minor shift, it's a significant ecological change. As average global temperatures rise, regions that were previously too cold for these insects to survive year-round, or maybe too cold for them to efficiently complete their life cycles and reproduce, they're now becoming increasingly suitable, more hospitable.
So longer summers, milder winters.
Exactly. That can translate directly into longer breeding seasons for the insects, wider geographical areas where they can establish stable populations, and ultimately a broader distribution of the vector itself.
And is it just about the bug surviving, or does warming affect the disease process itself?
That's another critical layer. It's not just about the bug survival range. Warmer temperatures can actually speed up the development rates for both the vector insect and the Trypanosoma cruzi parasite within the vector.
Okay, how does that work?
Think of climate change almost giving the parasite and the bug a biological fast-forward button. The Trypanosoma cruzi parasite, for example, can mature faster inside the kissing bug at warmer temperatures. This means the bug reaches the infectious stage more quickly after feeding on an infected host. It effectively shortens what's called the extrinsic incubation period, the time it takes for the parasite to develop to an infective stage within its insect host.
So the bugs become dangerous faster?
Potentially, yes. Even a seemingly small increase in average temperature, say 2 degrees Celsius, can dramatically shorten this incubation time in some models. This effectively accelerates the entire disease transmission cycle. Plus, some studies suggest warmer temperatures might increase the biting rates of certain insects due to metabolic changes. More active, biting more often. So
Wow.
you have potentially more bugs in more places, becoming infectious faster and maybe biting more frequently. All these factors combine to create a much more favorable and accelerated environment for disease transmission in new areas.
This isn't just some abstract scientific concept then.
Not at all. It's a truly stark illustration of how large-scale environmental changes, largely driven by human activity like deforestation and burning fossil fuels, are having very direct, very localized health consequences. Consequences affecting communities worldwide, often in unexpected and potentially devastating ways. It forces us to confront that very tangible, visceral link between environmental health and human health.
That's a truly sobering connection, linking our biggest global challenge directly to the emergence or reemergence of a silent disease potentially closer to home. And in this landscape where real environmental shifts are driving health changes, we also have to deal with that intense information battleground online. How does that calm, evidence-based public health messaging even begin to compete with all the sensational, fear-driven online chatter we talked about?
It is an enormous challenge, almost a Sisyphean task sometimes. Public health messaging, by its nature, relies on calm, factual, evidence-based communication. It presents nuanced risk information, probabilities, practical preventive steps. It speaks in data, often without those immediate emotional hooks.
Well, online chatter.
Online chatter, as we discussed, thrives on hyperbole, immediate emotional reactions, simplification, and often fear. These two communication styles are just fundamentally at odds. It makes the information landscape incredibly difficult for public health agencies to navigate effectively. Public health isn't really designed for virality. Misinformation often is.
So these agencies are in an incredibly tough spot. How do they communicate accurate, nuanced risk information effectively? How do they avoid either sparking mass panic or being completely drowned out by the noise and sensationalism?
It is a very delicate balancing act. It requires strategic thinking, innovation, and persistence. Agencies have to find ways to be present where people are actually getting their information, and that includes social media platforms, but they also have to meticulously maintain their credibility and their unwavering commitment to scientific accuracy. They need to use clear, accessible language, provide actionable, practical advice that people can actually use, and consistently point back to verified data from trusted sources like the CDC or the WHO.
Be authoritative but also engaging.
Exactly. The immense challenge is to be both authoritative and engaging, which is incredibly difficult when you're competing against content specifically designed to shock, provoke, or just generate clicks and shares above all else. It really requires building and maintaining public trust in an information environment that's often characterized by distrust, skepticism, and frankly, a preference for drama over data.
Which means the burden also falls on us, the listeners, the consumers of information, doesn't it? How can we navigate this overwhelming flood of information and effectively distinguish fact from fear, especially when a topic like kissing bug disease taps into such primal anxieties?
Absolutely. This really empowers you, the listener, to become a much more critical evaluator of the information you encounter. It means consciously making an effort to seek out and prioritize verified sources. Again, think the Centers for Disease Control and Prevention, CDC, here in the U.S., the World Health Organization, WHO, globally, reputable national health ministries, major research universities. These organizations are dedicated to providing accurate, scientifically vetted information.
They're not driven by clicks.
Their currency is public health outcomes and scientific integrity, not clicks or shares. So it's about questioning those sensational headlines you see, scrutinizing the original source of information. Where did this claim actually come from? Looking for consistency across multiple reputable outlets, rather than just latching onto the first or the most alarming thing you read or hear online. It's a vital form of digital literacy, maybe even media self-defense, that directly impacts your understanding and your well-being.
So what does this dynamic, this constant tug of war between evidence-based public health messaging and sensational online chatter mean for society's ability to respond to emerging health threats in the future? How do we collectively get better at parsing information in this age of constant digital input?
This dynamic fundamentally impacts our collective resilience, our ability to respond effectively to health crises. If we as a society cannot reliably distinguish between verified, actionable health information and, fear-mongering, misinformation, or disinformation, our ability to respond effectively to any emerging threat, whether it's a novel virus or an expanding vector-borne disease like Chagas, is severely compromised. It slows down effective public health interventions because people don't know who or what to believe. It erodes trust in vital institutions at the very moment we need them most. And it can lead to really misguided individual behaviors based on panic or misinformation, rather than on sound prevention strategies. Learning to navigate this information landscape, To parse information critically in this digital age is arguably one of the most critical public health skills of the 21st century. It requires a blend of media literacy, critical thinking skills, and a conscious, proactive effort from all of us to seek out truth and context, rather than just seeking confirmation of our fears or indulging in sensation. The kissing bug disease narrative, in many ways, is really a microcosm of this larger, ongoing struggle for public understanding and effective collective action in our incredibly interconnected, hyper-informed world.
This discussion has really brought home how certain health threats can remain hidden, just quietly escalating over years, only to manifest with these severe, often irreversible consequences decades after an initial, maybe seemingly minor event. It definitely urges continued vigilance and, I think, an informed curiosity from all of us, reminding us that sometimes the greatest dangers really are the ones that move in silence. Next time on Trending Unpacked, we'll switch gears completely from health scares to sports drama, unpacking the global buzz around the Mexico versus Japan soccer match. Thanks for joining us.